If you want to attend any ASIC verification engineer interview, so first they will ask you about the digital concepts, and then they will check your Verilog concepts, means hardware programming language. Then they will check your system Verilog concepts, and then they will check your UVM concepts. All this they will try to assess. So based on the cumulative feedback only, they will consider you for the role. So that's how it is. And if you are an experienced candidate, they will look for any projects you have worked. So in that particular project, for example, they are interested more in coverage now. So in that particular project, if you have worked on coverage, they will focus the questions on coverage. So then they will understand if you work practically, if you have really put your efforts to develop that, so definitely you will be having the basic knowledge and even the some advanced knowledge of the particular project related things. So the main focus will be that way. So if seeing your resume,
Ma'am, ma'am, as a 4 year experience, let's say I have 4 year experience and I have only worked on functional verification. I have not worked on coverage related stuff. It sounds okay with you? Like how does
functional verification in the sense, can you just give me an insight
so
exactly?
functional verification is that there is an IP, then that IP has a test plan, and according to test plan, generate the test sequence, and then make sure that DUT is basically matching the reference golden
Okay.
vectors
It's more than enough.
uh,
Everyone
for
at
4 years.
the start, everyone doesn't get a chance to work on all the things, right? Everyone doesn't get a chance to work on assertion. Everyone will not get a chance to work on coverage. So there are so many scenarios, but at least what they will expect is you send me your resume, Daman, once. I will let you know what kind of interview you might have if you apply for anything. Okay, and I will guide you for your interview preparation.
Ma'am, what is your email ID?
I will share it with you.
Okay,
You
thank
just ping me in WhatsApp. I will talk with you.
you. Okay.
Yeah. And we have some interview preparation courses as well our side. So I will let you know about it. I will explain you about it. If you are interested, you can take that course as well. Let us see if it is really required for you. Based on, I will do a small assessment. If I feel that we should do it, then we will do it. Okay. Okay, then anyone else have any queries? Okay, fine. So I'm assuming that you don't have any queries. So then I have queries if you guys don't have any queries, okay? So can anyone explain me what is the difference between code coverage and functional coverage?
So now code coverage is like how many lines of the code are covered, and for example, if statements and else statement and different statement. And functional coverage is the DUT has some input and the output pins,
Yeah.
and those input and output pins has some. It can take some range of values, and
Mm-hmm.
those range of values are defined as bins in cover point, which is defined inside cover group. And so we basically when we run the scenario, we basically sample it to see which all bins are covered. So that is functional coverage.
Yeah. Thank you, Daman.
And functional coverage is it's basically we have to define and sample it, but code coverage is automatically done by the tool. Something like
Correct. Correct. Exactly right. And you have given a proper explanation after attending a workshop how you will define that way you have defined, because the same question you had defined in the first day or second day in a very brief way, like in 2 lines, and the same person is explaining in such a detail. I feel good about it. Okay. And then anyone else want to try any questions? Let me know. I will ask them.
and yes, we can have some question and answer round, interview
Yeah,
question and
I
answer
have
round.
planned that today. Let's
Okay.
do that. Yeah.
And functional coverage is like to test the functionality of the like that RTL code. We are writing the test cases. So
Mm-hmm.
if that test case is sufficient to check the whole design or not, that
Yeah.
is only like. it
Yeah.
will cover that 100%.
You are tracking the progress of your verification. So how many test cases you have written? With those test cases, all the functional specifications are covered or not. Those reports you can understand the functional coverage. This is also a good point, right?
And on code coverage, like that it will cover all the functionality of that design or not.
No,
Like
no.
some
What
functionality,
it's about how well our design has got exercised in the particular.
like there should be no
Yeah.
redundancy, like no repeated code, right?
No repeated code. If it is statement coverage, all lines are covered or not. And if it is a branch coverage, the set of statements have been covered or not. The set of conditions have been covered or not. And path coverage means sequence of operations have been covered or not. FSM coverage means whether the transition from one particular state to the other state has been covered or not. All this come under the code coverage. Okay.
Okay.
Thank you
So
all.
we have to define like that if they
Yeah.
ask in interview.
Yes. So, you can define this way. If you define this way, anyone will understand that, okay, this fellow knows the proper flow of it. And then they will ask you some more in-depth questions. So if you have worked on it, you can say that I have worked on it. Otherwise, if you can, say that like I have a workshop with my curiosity. So this much knowledge I have grabbed. So I can do the same. Like this, you can tell. So, Shiva, can you please mute?
So, a functional coverage is like different functionalities of the design, whether they are executed or not, we can check via functional coverage.
Correct. Design specific.
And how much RTL code is, how much RTL code is excised by given test suite, we can check using code coverage.
Correct. Yeah. I am feeling so good to hear all the responses from you. Thank you. Okay, then let's start with today's session. So, you have practiced those codes and have you gone through those codes? Do you have any queries with those codes, which we have discussed yesterday? Okay, fine. I felt there is one more way in the cross means any coverage. I have written one code. Okay, I'll show this at the end of the session. Okay, let's go through some of the interview questions. Okay. I will also show one of the industry level protocol coverage. Okay. So how do we write for a protocol? I have taken one example. And tomorrow, if possible, I will cover for other different IPs also. But today I have taken for I2C. If possible, tomorrow we will do that. Before that, let us go through the interview questions. So let's make the session interactive because I have taken the question so that you guys can answer. If I only question, I only answer, that doesn't make sense. Okay. So how many bins are created in the following example for cover point? So based on yesterday's session, you guys can answer this, like how many bins can get created. So that
13.
like to try. Okay, Daman. Anyone is fine. Yeah. Daman, go
Here,
ahead.
I don't think so. We will get bins because here sampling is not happening.
Oh, actually, assume that it's sampling is happening. There's nothing wrong with this word.
That's a very good catch. Sampling is not happening, so yeah.
Thank you. But just assume that sampling is happening. This
Talking about
just cover point.
13.
I didn't put
So
that.
3. I think 4 for low bins and 9 for medium bins. So total 9 plus 4, 13 bins.
Oh, anyone else? If Raman is right or wrong? Sudha, can you comment on that? Whether he is right or not?
No, I am not sure. I'm just checking the code.
Okay. Anyone else? Kiran?
It's 5 bins.
Yeah.
5 bins.
For low 5 bins.
Low bins is automatic. Automatic bins we can take. So each one take 1 bit.
How
One
many
bin.
bins totally you just
Five, 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 five.
for low bins it's 5.
No, no, no. Low bins 4.
Huh.
Med bins is 1, I think. It is static in nature, I think.
Okay.
Bin.
Okay, fine. What about others? Supriya, what do
Oh,
you
yeah,
think?
good point. That's a good point.
Yeah, madam. Hello.
Yeah, tell me. Yeah.
Yeah, I think 13 bins, madam.
Okay. Others? Okay, fine. So low bins, you are right, Daman. It will be 4 bins, 0, 1, 2, and 3. As I told yesterday, when we take the square braces like subscript, in this, if we don't mention any value, so based on the number of possibilities, those many number of bins will get created. Means so now the possibilities are 0, 1, 2, and 3, right? When the range is 3, 0 to 3. So that's why here 4 bins will get created. And if he doesn't mention any subscript like this in the square braces, it means it will consider as only one bin. It will create one bin and it will check within
Yeah.
4 to 12 if any of the value is getting hit. It means this bin will get covered. That's how it will work. Okay.
Right. So
Yeah.
mid bin is it is also called the range bin.
Yeah, range. When we are providing range, so it is called as range, but it's not called as a range bin. But we can provide different ways, right? Here they are providing it as a range. The thing you have to observe here is this square brackets is not there here, right? So that's why the auto bins will not get created. Only one bin will get created. Having said that, if you have something like 5, one more value also here, anything whatever you have here, even then only one bin will get created. So people get
Ma
confused with that sometimes. That's why.
Madam, I mean to
How do you
say,
say it is
the
13?
low.
Can you explain me? In what
Hello, me.
analysis you have told that it is 13 bins? It's you, Shalu, who has unmuted just now. Yeah. How do
Sorry.
you say it is 13 bins?
Yeah, madam. Low bins is 4.
Okay.
Hello. Yeah. So you gave an explanation, and it's okay.
It's okay.
Mid bins,
How did
I counted from 4 to 5. 4. I mean, so I just counted to 4 to 12,
okay.
like that. But I was wrong. But I came to know after you said that based on the hit and misses, we can consider that bin
Yeah.
because of non square bracket.
Mm-hmm.
Am I right, madam?
Yeah, fine. So
Yeah,
let's go
the
to
way I understand.
uh,
Okay,
okay.
ma'am.
So then
Thank you.
what are the transitions covered by this following cover point?
Six, 3 into 2.
I have the answer is there here. Okay, fine.
Mm.
So the transition bins means we already saw yesterday, right? We can give a range. So A, B, C transition to X and Y. So from A to X, A to Y, then B to X, B to Y, and C to X, C to Y. All these combinations will come. So here, how many bins will get created in that case?
6 bins.
Correct. Yes.
Yes, ma'am. 6 bins.
Okay, fine. So
And
now,
then these bins are
Madam,
explicit, right?
one,
madam,
yeah.
sorry, have a one thing doubt, madam.
Yeah.
This symbol which is between A and X and A and Y,
Uh-huh.
I mean, what does it exactly says? I mean, it's pointing towards the next opposite thing, or does it has any significance operation?
No. Basically, we are trying to indicate here it as a transition. Transition means right? From C, after
Changing,
C,
yeah.
we should get X like that. It's a sequence. So usually in assertions, we call it as an implication operator. In implication also
Okay.
2 types differently. But here it's signifying about the transition. So you can consider this as a
Okay.
transition symbol or like that. Okay.
Mean to say we are saying that instead of C, we can take X
No,
like that, ma'am.
it's not like that. Transition in the sense, wait. It's like after A, for example, we have a clock here, okay, and then we have a signal A, and then we have
Okay.
we have something called value, okay, signal. So in this
Okay.
value, first at first clock cycle A should come, and the next clock cycle X should come. If this condition is happening, it means this bin will get hit. Means after A, X should come. It's not like instead of A, X should come. Okay. So the transition itself in the name we say, right? We transition from this to this, like that we say, right?
Madam, sorry, madam, I didn't understand. Please, will you explain again?
Okay. I mean to say, so did you understand this clock cycle? We have some clock here, right? You got
Yes,
it?
ma'am. Yes.
We have
Yes,
a
ma'am.
variable called for suppose value. Okay. This value can take A, B, and then C, X, Y. Like this, it can take some values. Okay. So
Okay, ma'am.
at first clock cycle, we got an value called A. Okay. The output of value is A. Okay.
Yes, ma'am.
Here. And the next clock cycle, the value is X. Okay. So it means,
Okay.
and the next clock cycle, it is something like Y for suppose. Okay.
Okay, ma'am.
Through this, what you understand is after A, X has come. Okay. So it means that we have a possibility like A to X has to be hit, right? So this condition will get hit. Okay. And then
Okay.
somewhere in the next clock cycle, we have B here. And then again, we got a value called X here. So in the, if this kind of scenario happen, then this bin will get hit. Okay, that's how it. Now is it clear?
Madam, so yes, madam. I have one more doubt.
Okay.
Sorry, can I ask you? Madam, you said in this case like A to transition X and B to transition X as hit cases. And then how come we can say miss case
How
if
can
it
we
is in the miss case? Yes, if it, I mean, this is the particular transition is getting missed. Hello?
see, for example, you have this kind of scenario is there. In that way, if you increase the randomization, the other scenarios also might get covered. This is how you have to understand is what is transition bins mean, what is its signification, and how those things are working. Those things you have to understand. So based on the requirement, nowhere you will get like A to X, A to Y like that. Now, based on your project, you will have some different parameters which you have to understand. But if you understand this, based on this, you will understand the complex things. Okay.
Ma'am, is it possible that
Madam. Okay.
Yes, Daman, go ahead.
Go.
okay, yeah, Sudha, if you have something, please go ahead. I can wait.
Sorry, can you be little louder?
Yeah, Sudha, please go ahead. I can wait.
Okay. Actually, Shalu. Yeah, go ahead. You were asking something.
Okay, okay. So, sorry, madam. The in case of A to X and B to X is okay. Then how come this A to Y is that this is also will come under hit case?
Yeah, see, in this entire simulation, for example, you have 1,000 units of simulation time, okay? 1,000 microseconds. In this entire simulation, anywhere else you can get this kind of scenarios. Whenever this kind of scenario happen, then this bin will get hit. If suppose in the entire simulation, these two bins didn't get hit, it means this scenario didn't come. Then these two bins will be not covered. Then it will show.
Madam, here only I got it out. Sorry. Sorry, madam. Please,
sorry,
don't mind.
Just ask your questions quickly, okay?
Okay.
Then it's okay.
Madam, in this hit case, I understood. Then I want to know if at all this is in a miss case, how it is described. How we will come to know this is in a miss case.
It will show
In the same the clock cycles, I want to know it.
It will not show as covered. Yesterday we saw some codes, right? Which things didn't cover. It showed like it is not covered and the percentage is 0 there. Then you will understand that okay, this scenario is not covered. So then you have to go to the test case. Is there any way you can try to give a stimulus in order to cover this scenario? That's how your analysis will be there.
So covered case, I mean the cover situation, if we get 0, then this is a miss case. You need to again check the test case
Yeah.
in order to get into the cover situation. Yes, ma'am.
Correct.
Thank you, madam. I
Yeah.
got it.
Okay. You were saying something?
Yeah, can we have the same value on both the side, left side also, right side? Let's say ABC and AXY.
Right. Usually,
Yeah,
for example, if it is some state, here it is some value. If it is some state, for suppose, that also makes sense because see, sometimes here, it will
let's say
get.
no state.
For example, we are in the setup phase. Okay, we have APP protocol.
Yes, setup phase, access phase.
Ideal phase we have. There could be a
Yeah.
scenario where in setup phase we have some, for suppose one data is started from setup is done and then we are in the access phase. Okay. In the access phase, the one data is there. The next data also will be there in the access phase only, right? So at that
Yes.
instance, if you try to check the transition from access to access phase, that will hit because there it is in the same state. So that
and so we should cover that transition also, right? In our cover, in our
we need to, we can. Possibility is there.
So it's allowed by system verilog. We can have same values also on left side and right side of implication operator.
Yes. In transition, don't call it as an implication here. Here you can call it as a transition operator.
Right.
In
It's an assertion.
It is, implication, madam.
Right. Assertion, it is implication.
Okay. Fine. So then we will see what does the following bin try to cover. Actually, we didn't cover this. If anyone can try to guess it, you can.
I think only one bin, maybe.
Yeah.
Madam, that 4 number is repeated for 3 times, if I'm not wrong.
Okay.
Or else 3 number is repeated.
What about others?
Sorry, madam.
One bin,
3
one
number
bin
is
only.
repeated 4 times.
Okay. Abhishek, you were telling something.
I'm telling one bin only.
One bin. Okay. Yeah. Okay, fine. So actually, Shalu is right. This is a kind of transition bin only, but it is a something called repetition. Like how it works is, for example, we have a clock cycle like this, and it will check at the pause edge. Now it is like 3 value should be repeated 4 times. So this is the value, and this star of 4 is nothing but how many times it has to be repeated. And this star is also called as consecutive. We have the same thing in an assertions also. We can even cover there. But just I'm telling you as the question has come. So here, if consecutive clock cycles means in this entire simulation, the 3 should be repeating at the successive clock cycles. Means here the value is 3, and then here the value is 3, and here the value is 3, and here the value is 3. So this way it works. If it is if it is a consecutive, but this operator is about consecutive repetition operator. There is one more operator where it will check the 3 should be repeated 4 times, but it can be anywhere. Means for example, here it won't be 3, but somewhere here again it will be 3. So what it will do is the entire simulation, the 3 has been reported 4 times or not is what it will check. It will not check like whether it is repeating at the consecutive clock cycles or anywhere else it is, that doesn't care. So that's how it works. But for now, let us focus only on this because here we have got a question. So you see that this means wherever this kind of scenario comes, it means that that particular value should be repeated about the so many number of clock cycles. Okay.
Are these are wildcard?
Which one? No, this is not wildcard. This is a transition bin only, a repetition transition bin. Okay.
The consecutive, right?
Yeah, consecutive.
Oh.
Okay. Yeah, this one. How many bins are created by following cross coverage of this?
Well, basically for cross coverage means so 16 bins for sub command and 4 bins for command. So 16 into 4, 64 for cross coverage.
Wow,
64 bins for cross.
yeah,
And for and for the command cover point only 4 bins. And
correct.
for the cross one it is 64.
Correct, correct. So everyone understood how he has analyzed this. We are doing cross CMD and sub CMD, right? First, we have declared one variable called CMD and then sub CMD, and we have written a coverage group at the rate of POSH clock, and then cover
Ma'am,
point. So here,
what
you can write the sample method. Then we are doing it as some clocking event, right? That's why it's a POSH clock. And then cross of CMD means the first variable, and then the sub CMD means the second variable. So the CMD has how many possible combinations? That is 1 down to 0, right? Means 2 bits basically. 2 bits means
ma'am,
2 part. Just wait, Kiran. Let me complete and then you can ask. Then 2
is it possible for without core point can we perform cross coverage?
Right, I think it is a bug. It is a bug in this code, I guess.
How it is possible, ma'am? Without core point, how can we perform cross?
If you have listen to the class properly in the cross coverage session, I have mentioned that if there is no cover point created for any of the particular variable and we are using it in cross, it may that it will create the cover point for implicitly by itself. It will take it. I will show you.
CMD is implicit, ma'am. What about sub CMD?
Wait, I will tell you. Just wait. I have told in the cross coverage slide also. See, when variable is used without a defined cover point for the variable, a cover point is explicitly covered. So it will be covered by itself. It will create a cover point. The tool will create a cover point by itself. The system Verilog provides the such mechanism. So if the cover point is declared, it's well and good. But if you are using in cross, if it is not declared also, it will work. Okay. I think you guys have forgot that. So now for CMD, we don't have a cover point, but still it will work by using cross. So this 1 down to 0 means 4 and 3 down to 0 means 16 combinations maximum. So multiplying those two, we will get the total number of combinations, that is 64. So total 64 bins will get created for this particular snippet. Okay. Then tell me what can be wrong with this following coverage code. And before that, anyone know what are default bins are?
No.
Okay. Daman, do you know what are default bins?
I think I may be wrong, but default means the remaining ones. The
Correct.
remaining ones which are not yet covered. So like
Correct.
0, 1 are there. So the remaining ones are come under default. I'm just guessing.
Correct. Yes. So now here int is given, right? We have declared the variable through int. It means int by default will have the 32 bit, right? So inside entire 32 bit, we have covered only 0 and 1 here. So the other bins which is there that we are declaring as a default. It means 2 power 32 minus 2. Whatever number of values are there, those all values come under this default bin. Okay. So what can be wrong with the following coverage code? This might be tough for you guys, so let me answer this. So it is like If we have only 2 bins as a low bins, we have declared, and the rest all are given to the default bins, it means while doing the coverage, it might get crash also. Because so many number of bins, we cannot give it to as a default. And the other bins we shouldn't be having very less number of bins. So usually default bins, it is recommended to avoid. Until unless it is very necessary, we don't use. Usually in industry level, and so they will not at all use this default pins, as of my knowledge. So it's better to avoid the default pins, basically. Okay.
Yeah, got it, ma'am. One question, ma'am, regarding the low bin. I'm missing something. So do we need square brackets here in the low bin?
No, it's the curly braces only. If you want to give the range, no, then it will be square braces usually. Anywhere in the constraints also, if you see system Verilog, the constraint will be enclosed within the curly braces, and then the particular range which we are giving, that will be with the square braces.
So I thought like low is having 2 bins, so low should be a vector, so we need curly braces. So okay, I missed that.
Yeah.
Okay.
Fine.
Can you
Madam,
please
Ah,
explain
yeah.
default name once again?
okay.
Default.
Kiran, can you be little louder? What did you ask?
Why? Default, ma'am. Can you please explain again? Default.
Madam, I have one query. Sorry. Default
You please
is
wait,
is it
let him
considered as
complete.
ignore pins?
Let him complete and then I'll get back to you. Just don't interrupt.
Okay, okay.
Yes, Kiran, just tell louder. I didn't get you what you are asking.
Repeat once again default, ma'am. Why we are avoiding default pins? What is the reason behind that?
See, default bins means, as Daman explained, it's like the bins which we have written as a cover point, and the other bins means they won't get covered, right? We are not writing that as a coverage point. So it means that the rest all things are remaining bins are come to default. So we should not use the default, because see, if you see in one bins we have 0 and 1, only 2 values. So now that if you write default like this other bins will have as int means 32-bit data. So 32 bit in 32 again, 32 means it has to be checked like 2 power 32 number of combinations, right? So
Yeah.
it's writing 2 values in bins low, and 2 power 32 minus 1 will be assigned here. So we should not, that is not a recommended way to do to use default, because so many values getting into one bin, it's not recommended. That's why the tool might get crashed that way, or something, there could be some issues. That's why it is recommended to avoid the default bins. It's better to always take whatever bins we are interested. Otherwise you can just provide an implicit bin so that it will create the auto bins by itself. That's
Is it possible in the place of bit int, in the place of int? Shall we take bit?
in place. Can you be just
Bit, ma'am.
clear? I'm sorry.
In the place of int.
Int what we want to take?
In the place of int, shall we take bit? Is it possible?
Yeah, you can take anything. There is no rule
At
that
that time, default bin, how it will
then
work?
it will work, because only bit means only one bit, right? It will be of just one bit. If you are providing bit 31 down to 0, then it will be the same. There is not gonna be any difference. Okay. Basically, guys, let's join the next session, because it's gonna end.
Same link? Using same
Yeah,
link?
same link.
Okay, thank you.
What are the different ways in which a cover group can be sampled? Can anyone answer?
So either it can be sampled using cover group dot sample method by creating an instance of cover group, or second way is we can avoid calling the sample method, and it can be sampled at the positive edge of the clock or negative edge of the clock based on the cover group definition.
Correct. So why do we? It's means both are good only. Both are useful. In which scenario you think the sample method should be used? In which scenario you think the pausage clock should be used?
And when we want to maintain the synchronization with the positive edge of clock and with the, like everything should be synchronized with the clock, I think this pause edge clock is preferred.
Okay.
Otherwise, maybe if we are not don't care about the edge, rising edge of the clock or falling edge, then we can use the sample method basically.
Okay. That is
Because in the transition, the sample method is not a very good
approach.
function to call. In transition, we rely on the positive edge. So
Correct.
that is one scenario that comes to my mind.
Okay. What about others? Can anyone have any guess? Supriya?
Madam, I think in cross coverage sample is, sorry, hello?
I don't think so. Anything related to cross coverage or coverage, that doesn't depend
Okay,
on that's, but still okay. You have given a try. What about
okay,
others?
madam.
For transitions, I think you can use at the rate positive edge of clock. Why? Because it is more suitable, and for variables, you can use generally by dot sample method.
Okay.
And what is the main difference between dot sample method and clock edge?
Sample, see,
Both
both are used
actually
for sampling only. But if you want to give any particular clocking event at the positive of clock, you want to sample your cover group. At every positive of clock, your cover group will get sampled that way. Or if you just write coverage dot sample also, it means like it will sample whenever there is a change in any of the cover points or any of the particular variables which are being used in cover group. So in my explanation only the answer relies. So whenever there is a scenario where, for example, there is a signal called A, which has to be continuously monitored by us. Means at every clock edge we want to understand its behavior. At that time, it's good to sample at any clocking event, like any positive clock or negative clock. If there is a scenario where we need not check at every clock edge, means for example, there is a scenario called I2C read write. Okay, so at every clock edge we need to check like whether it is a read, if it is changing to write, like that. If there is a scenario, is a requirement, then we can use a clock edge at the rate of positive clock. But there could be something that will happen only in the entire simulation, only once that will gonna change. So isn't it more tedious, or it is more power consumption if we, though the requirement is only one time, it will change in the entire simulation, but still you are forcing it to change it every forcing it to check whether it is changing at the every passage of clock. So in that scenarios, it's better to use dot sample method. Got it? Is it clear, or did I confuse you all?
It's clear, ma'am.
Okay, sorry.
Now for every clock edge, we have to use clocking event, no?
For if you want to sample at every clock edge, then you have to give it the rate of posage clock. But there is a scenario where you don't want to check it at every clock edge. Only you want to check at any once in the simulation. Then you can use dot sample method. Both are for sampling only. It's just depending on your requirement. You have to choose wisely which is. Even if you choose that, also it won't be a problem. But the optimized way is to choose like this. That's it.
Only total two method for sampling.
Sorry.
And for sampling, there are two method or three methods.
Two methods. One is clocking event. Clocking event means you can give positive clock, negative clock, anything with reference to clock. And if the other thing is dot sample method.
Okay, got it.
Okay. I'm recording, right? Yeah. Then can we have cross coverage between two cover groups or two different cover points which are residing in two different cover groups? Basically, the cross coverage is possible for two different cover groups or not is the question. Yesterday also we had this question, right? I told tomorrow I'll answer. So the answer is no, because we have already discussed the reason yesterday. That is like they will be sampling at a different instances, right? So the synchronization issue will be there. That is one thing because of which we don't prefer have an option to do the cross coverage between two different cover groups, and even the two different cover points in the different cover groups. That is also not possible because the first cover point which is there in the first cover group will sample it at its own pace, and the other cover point in the other cover group also will sample it at its own pace. This synchronization will not be there. So that's why both are not possible. Okay. And then the can cover points inside a cover group reference hierarchical signals in a design. Means using any hierarchy can be used in the cover points or what. So yes, it is possible by giving a hierarchy also. I have taken one example after this slide. You can observe that. So how can we pass the arguments to a cover group and when will that be useful? Can we pass an arguments to a cover group? Like how in task and function we pass the arguments, like in the same way can we do it for cover group? What do you say? Is it possible or it's not possible? Just give a guess because we haven't discussed so far, but just give a
It
guess.
should be possible. Just a guess.
Yeah. So it is possible actually. That is like we have a cover group here, just like in task and we give the reference keyword, right? So using reference keyword, we have to declare the arguments, and then here you are giving some input string name. So here we are in a cover point, we are, this is the label cover point X, cover point Y, and then we are doing the cross of these two cover points. And in the initial begin, what we are doing is we are creating it by giving a hierarchy. So here the question was there, right? Can we give through the hierarchy? It is possible. So inside you are giving a hierarchy. Hierarchy means basically, for example, your test is relying, you know the architecture, right? So in the architecture, the entire top will be there inside the test, and then inside that env, inside env you will have an agent. In agent like that it will be there, right? So if you want to locate the agent, you have to write like top dot test dot env dot particular agent, right? So that is called a hierarchy basically. So here we are trying to locate X. X is there in mod 1. Mod 1 is there in top. So top dot mod 1 dot X. This way you can refer, and this will be useful. And what do you think, like passing the arguments will be useful? Why do we need to pass the arguments like this? Is there any use case you can think of? Any one of you can try. We haven't covered this, so just give a try. You can be wrong also. What's the problem?
If same variable is there at different hierarchical levels, then I think this is useful.
Okay. What about others?
So mod 1 and mod 2 are agent, and different agents have different this driver sequencer and monitor.
Mm-hmm.
So top is like the top one, and then we have test.
Actually, I'm not asking about the hierarchy. I'm asking about like
So
passing the arguments.
yeah.
That
So basically, we don't need to write this cover group again and again for different X and different Y, right?
Yeah.
We can just write one cover group, and so we can avoid code redundancy, I guess, by using this hierarchy. That is one use case according.
Here we are creating a memory constructor.
You are creating the. Hello.
Here we are trying to use the constructor with the arguments, but there is no function defined with the constructor here.
Yeah, this is actually some example basically to show like how this has been created. Okay. So because we don't have the entire code, right? So this is in initial begin will be in somewhere else. There we are creating it and we are providing the hierarchy basically of this particular cover point. We are using it. So this is not related to something here. This is, for example, somewhere in the module or top module we are writing, and this we are writing in some test file or somewhere, so for suppose that's why, or there are some other components also. So for you I cannot get all the things, right? So in small snippet we got it. So you can ignore those why they are not declared or not. Just try to understand like what is the purpose of it. Okay, Aditya? But it's a good observation. I'm just trying to explain you guys in this way. So one thing is like Daman, what he has told, it's correct. Basically, you don't like how task and function works, right? The same way, right? We will we will pass some statements, set of statements in particular task and end task, and you will call that task whenever you require. So basically, the purpose of reuse will get served using this way, passing the arguments. Okay. So that is about this, and then we will have a look of some code. Okay, then again we'll come back because lot of theory also will scare you guys. Okay, so this is one of the coverage code for the I2C. So here, see, if you can see, if you observe the class, coverage class is extended from UVM subscriber. I think most of you are not aware of UVM, but that's okay. Let me tell you, just remember it for your knowledge. When you get through the UVM concepts, you will definitely understand why we are using all this. In UVM, it's like we will be having some predefined classes. So you can inherit your particular class with that particular base classes so that you can use the some of the functions or some of the properties related to the UVM subscriber, and you can use in your particular class. For example, the coverage, for example, we have a driver. The driver will be extended from UVM driver. Monitor means it will be extended from UVM monitor. So whichever component you are using for that particular specified base classes are already available. So for the coverage class, you are extending it from the UVM subscriber. Okay, and you are passing the sequence item. So here we need to pass the exact transaction what we are doing. So this analysis code, these all are different concepts which I cannot cover in this particular workshop. But if you know that, it's well and good. If you doesn't know it, you just ignore it for now. And once when you get a chance to learn UVM, then you can get through those concepts. So let us go to the cover group basically. So inside cover group, we have these are the labels, and we have taken some cover point. So cover point S dot slave address. S means this is a handle of one sequence item. So we have one transaction class where the transaction we are taking an object, through that we are accessing. Means in the sequence item, we will be having these variables. You again can think that where are this variable coming from? But here there already would have been declared. So that's why we are using dot and trying to access those. Okay.
And one question, I'm sorry to interrupt. Regarding the sequence item S on line number 6.
Yeah.
So this is the handle, right? So we create a handle using this.
Yes.
But what about the new operator? So we need to have S equals to new also, right?
Correct.
Before
We
we
need
can
to have it. Here we didn't
in
do
build
it.
phase.
Only we have to
In
have.
build phase, yeah.
You can do it in build phase. They have created the coverage, but they haven't created this sequence. You have to create it.
Okay, thank you.
Yeah. So before using it, we need to create it, and then then we have like bins. SLV means the slave. As bins, you can have some name, and then you can you all these things you know, right? Like these are the values which we can cover. Let us see if there is something new which we can understand from this other than what we have covered so far. This cross coverage also you guys know now. So like this way, we will write a cover group in any of the actual industry protocols or in any test cases. Okay. So here, then we have some data where cover point, this is also fine. We are doing something here. Yeah, this we will try to understand. There is a stuck label where we are trying to do the cross of address and registers, right? Registers and data. So all three things we are doing. And then we are writing like bins zeros is equal to bins of data dot data zeros. So how is this happening is bins of data means this cover point. So with this, they are trying to whichever bins they have got it here, those things they are using means using the other cover point also we can try to create the other bins. So this is something which you can think of this way also. Bins of means those particular cover point bins will come here. Okay. And then we have this illegal bins. You can see there can be some scenarios like where you are trying to check the error, right? So for acknowledgement error, if suppose the bin value, there could be some like decoding will be there. 0 means normal response, 1 means okay response, 2 means slave error response, like that you will be having. So in that case, you can write like whenever acknowledgement error has hit third bin, it means it's an error bin. So in that case, you can write an illegal bin. So through that, you can quickly understand that there is some response which has been corrupted. That's why we are getting error response. That way also you can use this coverage like illegal. So in UVM, you will be having different things like you have to create it. We will be having different phases. So if anyone is interested to take the UVM related course, you can reach out to me. We can discuss about it. But for now, you can ignore because you will not understand even if I explain here. Okay. And then,
Ma'am,
yeah,
what is the main difference between bins of and intersect?
pins off and intersector. So do you
Yes.
know what is intersect?
I don't know, sir. So that's why I'm asking you, ma'am.
Exactly what is intersect? Do you know?
Both functions
Common.
are same, I think.
No. It's like the word intersect meaning, in English, in intersect
Yeah,
means.
it's common elements. Common elements.
I'm trying to explain you already. I'm not asking you why you don't know or something. I'm trying to explain you like intersect means, for example, any of the thing. Intersect means it's a common things between two, right? So intersect means if suppose you are doing intersect of this bin and this bin, whatever the common bins we have values in those two bins, that will come under intersect. Bins of means the all the bins will in that particular cover point will come. So that is the thing difference. Okay, and then in run phase, we can sample that coverage. We will be creating the instance of the coverage, right? So that we can sample it here. Okay. So this is the display to check here itself. If usually tool will be there means through tool we can. So this is some overview as news. Yesterday someone asked me like, can you cover some advanced things? I think Anil or someone. He didn't join today. He has joined. Okay.
No, I was in. Yeah, joined.
Yeah. So have a look of this. Maybe you can get some insights like how the complex things will be there. Okay. Fine.
Then this sorry to bother. Like this run phase. So basically, according to me, the run phase means that that the
hmm.
driver has driven the pins or the interface to the DUT,
Mm-hmm.
and then DUT is running. So that is the run phase of, and when DUT is running, DUT will send the output to monitor,
Mm-hmm.
and then the monitor will send it to this one, this coverage module
So
through analytics.
each component we can have run phase. Means driver can have its own run phase, and coverage can have its own run phase. Test can have its own run phase. Every component can have its own run phase. Correct?
Okay.
If you don't know, it's like that. Okay. For every component, it can have run phase, and in UVM, all the run phases will execute parallelly.
Parallelly. Okay. Okay.
Yeah.
Okay. Got it.
Yes. So let's go back to our slides. Okay. So there are some 3 more slides, then we will end up the session. So here there are something called coverage options. Actually, someone asked me, I don't remember, I think Anil itself or someone, or Abhishek, I guess. Someone asked me the instance, per instance means what? We are giving like option dot per instance is one in our all the codes, right? So why is it? So there are different coverage options available. That is like you can set the goal also. Like for the coverage option dot the instance means particular thing dot this goal means the cover group dot goal. If you put this way, you can set the goal. Usually the goal has to be set 100%. At any instance you can decrease also, but usually it is recommended to put 100% itself. Okay, and then you can give here, you can actually self read this if you want, but still if time is there I will explain. So name is string means you can specify a name for that particular cover group instance, and you can give a comment also. For example, that option that instance dot the comment, if you give, you can put in the string enclosed with the double quotes, and you can write something if you want, like if you want to pass some information or message you can write. Likewise you have the different options. You guys can self explore this, and if still you have any queries you can ask me. And you had asked me, Daman, like in the second or third session, saying that what is the default auto bin max, right? That is 64 for auto bin max. And for cross coverage, no, it is like n number. It can have any number of thing. There is no something like default. Okay. And then
Okay, so that default example interview question that we saw, where 2 raised to power 32. So in that case, we already covered 2 bins in the one cover point, and second cover point was default.
is, but there is something called auto bin max we had used, right? If usually in implicit bins, it is like it will create any based on the number of combinations, right? For example, it is 3 down to 0, then it will take 15 combinations, 16 combinations, 0 to 15. But if you want to limit that implicit bins explicitly by with some variable, there is an option, right? That you can use like auto bin max. So that day you had asked me like auto bin max, if it don't mention any value, defaultly what it will take. So that the maximum number of what we can give is 64. That I wanted to tell you.
And if we set it, can we use this with default also? Let's say if we set this auto bin max, and we also are using default variable.
Code and check like how it will behave.
Okay.
And then
Thank you.
we have some coverage option restrictions, means like which coverage option we can use in can we use in cover group, can we use in cover point, can we use in cross. There is a table. You guys can just self explore this, like in cover group what is allowed, and cross what is not allowed, cover point what is not allowed. So just you can keep it in your mind. These are not that important. If it's good if you have a knowledge, that's it. Okay. And then we have something like coverage built-in methods. Within all this, the important thing is this sample method, because we need to sample the cover group which we are declaring it, right? That is very necessary. So that one, and the other one you have to thing is this get coverage. Usually we can use this system function or this also get coverage, and you can fetch the what is the coverage report, means what is the coverage number we have got, if you want to display it in your any of the report. So that dot get coverage, like that you can fetch that value and you can use in dollar display and you can display that particular value. So that way this will work. Okay. And so that's it for this about this presentation. I have one more code. Let me share it with you all. That link is not reflecting in the presentation, so let me open it and show it to you guys. Any queries for anyone?
Can you share the EDA link so somewhere we can practice the concepts that you have taught us?
Actually, I have tried yesterday.
Okay. Is it in the group Risky Projects?
Actually, it's in the group. Okay, Risky project. You are in the Assertion group also, right?
No, I'm only in the Risky project group.
Okay, you just ping me. I'll share it with you.
Yeah, sure. Thank you so much.
It's the same thing.
Madam, I have one. Hello,
Yeah, go ahead.
madam. Exactly this functional coverage in verification part, where is commonly used? It's in monitor or scoreboard. Hello.
Just a minute.
Okay, ma'am.
Usually, means you can use in the I told right in the ENV we can have a coverage file and there we can put your coverage model everything over there. Means we can have a fun. Means it all depends on your architecture where you have put your coverage. So basically, in the ENV usually we put the coverage models where we can.
Madam, I'm asking in UVM methodology, madam.
Yeah, in UVM methodology or anywhere in SV, anywhere.
So,
Guys, actually that link is not opening, so I will share you that in the next session, or if possible, I'll share it in the group. So, yeah, you can go ahead with your doubt and then we can end up the session.
yes, madam, I mean to say assertions and functional coverage
Yeah.
Are especially meant for debugging process, no, madam?
So this is basically for the functional verification coverage, means so the test anything to verify the design only. So the to verify the design we have written test cases. The test cases how well the it has verified the design. There should be some metrics, right, to cover those. So that's why we have all this functional coverage, code coverage to track the progress of the verification. And assertions are something like which you want to monitor them for the entire simulation. There those assertions will take the role. So we will discuss about the assertions quickly. I think from tomorrow or day after tomorrow. If I have something related to coverage, which I feel that we haven't covered it, we will discuss about coverage. Otherwise, we will start with assertions from tomorrow.
Madam,
Yeah.
sorry, madam. The thing is that, of course, if at all, this assertions are used in design also, apart from the verification part. Assertions and functional coverage are just used in design, apart from the verification part. If it is used in design, then what is the use of using these methodologies?
I didn't get your question actually. Design where the assertion has come. In verification,
No, madam.
we'll be having the assertions. Right? Okay, guys, if everyone is done, you guys can leave. I will talk to her and we will end the session.
Okay.
Or otherwise, shall you just ping me your doubt? I will answer you. Okay.
Okay. Done, madam. Done, ma'am. Thank you, ma'am.